TechDaily.AI, your source for technical information. This deep dive is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged and VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.
So artificial intelligence, it's changing everything, right? And behind it all is just this massive amount of data.
Absolutely huge and growing all the time.
Which brings us to the crunch point.
Yeah.
How do we keep these AI systems safe, and how do we actually manage all that data effectively?
Exactly. It's becoming, well, critical.
And you're listening because you want to get a handle on this whole complex area, but without getting totally lost in the jargon.
And that's our mission today, really.
We're going to try and pull out the most important stuff about securing AI, managing those data pipelines, basically hit the highlights on the risks, the protections, and the best ways to handle these giant data sets that AI needs. Okay, let's jump in. This reliance on AI, it really ups the stakes for security. It's not just about protecting the code, it's making sure the AI does what it's supposed to, that the data it uses is trustworthy, and crucially, that sensitive info doesn't leak out or get misused.
Yeah, and the security risks here, they feel different somehow from the usual cyber threats we talk about. AI has its own vulnerabilities.
Definitely. Think about the data breaches. AI systems often handle incredibly sensitive stuff.
Right. Personal details, financial info.
Exactly. So if that data storage gets hit, the fallout can be massive. We're talking GDPR, CCPA violations, huge fines, reputational damage, you name it.
Which is why things like strong encryption and secure ways for systems to talk to each other are just table stakes now.
Absolutely non-negotiable. And then there's the whole issue of bias creeping in.
Ah, yes. Bias in AI, that's a big one.
It really is.
Yes.
If the data you train an AI on reflects, existing societal biases, say in hiring or lending,
then the AI just learns those same biases.
And can even make them worse. It can lead to really unfair outcomes. So you got to actively look for diverse, representative data.
And build fairness checks into the algorithms themselves.
You got it. Plus regular checks, ethical oversight. It's a continuous process.
Okay, that leads to something really interesting, these adversarial attacks. It sounds almost like trying to trick the AI.
That's a good way to put it. You make tiny, often invisible changes to the input data, tweak a few pixels in an image, say.
And the AI gets completely fooled.
It can, yeah. Like an AI reading traffic signs might suddenly see a speed limit sign when it's actually looking at a stop sign.
Wow. And that's not just theoretical, right? Imagine a self-driving car.
Exactly. The real-world consequences could be incredibly serious. It highlights a unique vulnerability.
So how do you defend against that?
Well, one key technique is adversarial training. Basically, you show the AI these tricky, manipulated examples during its training phase.
So it learns to spot them.
It learns to be more robust against them, yeah. And just generally being really careful about validating the data you feed in helps catch weird anomalies.
Okay, so you can try to fool the AI, but can people actually steal the AI model itself? Like copy it?
Yes, that's model theft, or sometimes called model inversion. Attackers basically bombard the model with queries to try and figure out how it works internally.
That's a huge risk for intellectual property.
A massive one. So ways to fight back include limiting how much info someone can get from the model's answers and using things like differential privacy.
Differential privacy. What's the simple version of that?
Think of it like adding a tiny bit of carefully calculated noise or randomness to the model's outputs.
Ah, so it fuzzes things up just enough.
Just enough to make it really hard for an attacker to reverse engineer the model or pinpoint specific training data points, but without messing up the usefulness too much. Plus, standard stuff like strict access controls and monitoring usage patterns.
Got it. Then there's messing with the training data before it even gets to the AI data poisoning.
Yeah, data poisoning. Slipping malicious data into the training set to deliberately skew how the AI learns and behaves.
That seems incredibly damaging.
It can be, which really underlines why careful data curation and validation are so vital. You need strong processes to vet your training data.
Regularly cleaning it, checking for outliers.
Exactly. Finding and removing those bad inputs. And sometimes using algorithms that are naturally less sensitive to dodgy data points can help too.
Okay, one more classic type of attack. Just overwhelming the system, right? Denial of service.
Yep, resource exhaustion or DOS attacks. Basically, flooding the AI system with so many requests it just grinds to a halt.
Which could knock out critical services.
Absolutely. So mitigation involves things like rate limiting capping requests from one source and load balancing, spreading the work across multiple machines so no single part gets overloaded.
Okay, so those are some of the, let's say, established threats. But AI doesn't stand still. Generative AI, that's bringing a whole new set of worries, isn't it?
Oh, absolutely. Generative AI, the kind that creates text, images, code, introduces some really sophisticated new risks.
Like phishing attacks.
Exactly.
Mm-hmm.
But on steroids. AI can craft these incredibly convincing fake emails or messages, personalized, using details scraped from online, making them way harder to spot than the old Nigerian prince emails.
That's quite chilling, actually. And what about prompt injections? Is that like tricking the AI again?
Sort of, yeah. It's manipulating the input you give a generative AI, the prompt, to make it produce harmful, biased, or just unwanted content,
Yeah.
getting it to bypass its own safety rules.
And the idea that AI could write malware.
That's a big concern. The potential for AI to automatically generate malicious code, maybe even code that can adapt itself to evade antivirus software. It's something security researchers are watching very closely.
And privacy with these large language models, the LLMs, the engines behind things like ChatGPT.
Huge implications there. These models learn from vast data sets, and sometimes they can inadvertently spit out sensitive information they learned during training.
Or even reveal details from the prompts people give them.
Correct. If they're not built and managed carefully, they could leak private data. So again, things like differential privacy during training, careful data anonymization, they're really important.
Man, it feels like a minefield. We definitely need some structure, some consistent ways to approach AI security. That's where frameworks come in, I guess.
Exactly right. Frameworks give you a structured approach, a roadmap, sort of, for identifying, assessing, and dealing with AI security risks.
Like the OWASP POP 10 for LLMs.
Yeah, that's a great example. OWASP put focus specifically on the security risks unique to large language models. It's like a practical checklist for developers building or using LLMs.
And Google has one too, SEIF, Secure AI Framework.
Yep, SAIF. Google's approach emphasizes securing the entire lifecycle, the algorithms, the data, the infrastructure they run on, from the drawing board all the way through deployment and operation.
So thinking about things like encryption, access control, monitoring.
All of that, making sure the whole system is robust and stays trustworthy over time.
Then there's NIST, the National Institute of Standards and Technology. They have an AI risk management framework.
Right. NIST takes a broader view. Their framework offers guidance on managing a wide range of AI risks, not just security, but also things like bias and reliability. It's about promoting consistent practices and encouraging organizations to really think through the potential downsides.
It sounds very comprehensive.
It is. It helps organizations develop a structured process for identifying, assessing, and responding to all sorts of AI-related risks.
And Europe's cybersecurity agency, ENISA, they have one called FAICP.
That's right, the Framework for AI Cybersecurity Practices. ENISA's approach emphasizes looking at security throughout the AI lifecycle, starting even before development kicks off, with things like pre-development risk assessment.
Focusing on data analysis early on.
Yeah, analyzing data for potential biases or vulnerabilities right at the start, and setting up strong governance for AI security.
Okay, so we have these frameworks as guides. What about practical steps? What are some key best practices organizations should actually be doing right now?
Okay, so several things stand out. For generative AI, definitely customize the architecture. Build in security from the ground up, access controls, threat response mechanisms, model potential threats during development.
And hardening the models themselves. We talked about adversarial training.
Absolutely crucial. Harden those models and rigorously sanitize inputs, clean and validate everything coming in. Especially for generative AI, careful prompt handling and filtering are essential to block malicious uses.
Makes sense.
Then, continuous monitoring and logging. You need visibility into what the AI system is doing in real time to spot anomalies quickly.
And have a plan for when things go wrong.
Yes, an AI-specific incident response plan.
Yeah.
Know exactly who does what if there's a breach or a security event.
It's fascinating, though. While AI presents all these risks, it's also becoming a powerful tool for security, right? AI-based security solutions.
Absolutely. It's a double-edged sword. But the defensive side is getting really strong. AI is transforming cybersecurity.
How so? Like with threat intelligence.
Exactly. Threat intelligence platforms use AI to sift through mountains of data, news reports, forum discussions, dark web chatter to spot potential threats proactively before they hit.
And making things like intrusion detection systems, IDPS, smarter.
Much smarter. AI can learn normal network behavior and then flag unusual activity that might indicate an attack, often much faster and more accurately than rule-based systems.
What about SIEM systems, security information, and event management?
AI is a huge help there too. SIEMs collect logs and alerts from all over your network. AI can correlate all that information, connect the dots, and surface the real threats much more effectively, cutting through the noise.
And phishing detection. We mentioned AI making phishing worse, but can it also help detect it?
Yes, definitely. AI analyzes email content, sender reputation, behavioral patterns, lots of subtle signals to identify sophisticated phishing attempts that older filters might miss.
So better email security overall.
For sure. AI-powered solutions offer broader protection against all sorts of email threats, malware, business email compromise, BEC, spam.
And protecting our actual computers and phones. Endpoint security.
Yep, AI is big there too. Analyzing process behavior, file characteristics, network connections on the device itself to detect and block threats like ransomware in real time.
Okay, so we've really hammered home the security side. Protecting the AI. But none of this works without the data. It's the foundation, isn't it?
Utterly fundamental. Reliable, well-managed data is everything.
Which brings us to data versioning. What exactly is that, and why is it so vital for AI?
Okay, data versioning. Basically, it's like creating a save point for your data set. You assign a unique tag or reference to a specific collection of data at a specific moment.
Like version control for code, but for data.
Precisely. That's a great analogy. It lets you track exactly how your data changes over time. And it's super important in AI. Think about development speed. If you mess up a data set, delete something crucial, corrupt it somehow.
Oh man, that sounds like a nightmare with huge data sets.
It can be. But with versioning, you can just roll back to the last known good version. It's much faster and way less error-prone than trying to manually fix or recreate terabytes of data.
Like an undo button for your data lake?
Kinda, yeah. It speeds things up immensely and cuts down on errors. Imagine training a model, getting weird results, and being able to instantly revert the data to exactly how it was for a previous successful training run. That's invaluable for debugging.
Especially now with data coming from everywhere being used in so many ways.
Exactly. It helps manage that complexity. It brings disciplined software engineering practices like reproducibility and traceability into the data world. You know exactly which data produced which result.
So how do people actually do data versioning? What are the methods?
Well, there are a few ways. The simplest maybe is just full duplication. Every time you make a change, save a whole new copy.
Sounds expensive.
No.
Storage-wise.
Terribly inefficient for large data sets, yes. Another way, often used with structured data, is adding metadata columns, like valid from and valid to records, tracks history without full copies.
But maybe limited in flexibility.
Can be. Then you have what some call first-class data version control systems. These are built from the ground up for efficient versioning.
How do they work differently?
They aim to store only the changes between versions, not duplicate everything. They often use pointers and clever indexing, making it really efficient to switch between versions, create branches for experiments, compare versions, things like that.
You mentioned LakeFS as one example, inspired by Git.
That's right. LakeFS uses concepts like commits and branches, familiar to software developers, but applies them to data lakes, often stored in object storage. It avoids massive data duplication by managing pointers to the underlying data objects.
And that helps with things like machine learning model tracking.
Absolutely. You can tie a specific model version directly to the exact version of the data it was trained on. If the model drifts or fails, you can instantly access that precise data state to understand why.
Or debugging data pipelines.
Yep. If an analytics report suddenly goes wrong, you can rewind the data to the state it was in when the report last worked correctly, making it much easier to pinpoint where the data error was introduced. Reproducibility is key.
Any best practices for using data versioning effectively?
Good question. Definitely think about managing storage. Use time to live, TTL policies to automatically clean up old, unneeded versions.
Don't just keep everything forever.
Right. Also, try to make your versions meaningful. Instead of just versioning by date, maybe version based on pipeline stages like data cleaned v2 or features engineered v3. Semantic versioning.
Makes it easier to understand what each version represents.
Exactly. And leverage it for collaboration. Different teams can work on different branches of the data simultaneously without stepping on each other's toes, then merge changes back in a controlled way.
Okay, that makes sense. Now, let's shift focus slightly to how data moves through the AI lifecycle, the data pipelines. Can you walk us through the typical stages?
Sure. The AI data pipeline is the whole journey data takes. It usually starts with raw data, ingest, gathering data from all sorts of sources. Think logs, images, sensor data, text,
Getting it all into one place, basically.
pretty much. Then comes data preparation. This is huge. Cleaning the data, transforming it, formatting it, maybe labeling it, getting it ready for the AI models.
Then the actual training.
Right, training the models on that prepared data. This can involve multiple iterations. After initial training, there's often fine-tuning, adapting a pre-trained model for a more specific task.
And once the model's ready,
Then it's inferencing or deployment, putting the model into production to actually make predictions or decisions on new live data. And finally, archiving, storing data models long-term for compliance, future retraining, or analysis.
and I'm guessing the storage needs change quite a bit between those stages.
Drastically. Raw data ingest. You're talking massive volumes, often unstructured data. Object storage is usually the go-to here. It's scalable and cost-effective for bulk storage.
But Amazon S3 or similar.
Exactly. But then for data preparation, you often need faster access, lots of reads and writes, low latency. So high-performance file storage often makes more sense there.
And for training, that sounds intense.
Very. Training often needs super fast, parallel access to data subsets, especially with GPUs involved. So again, high-performance file storage, sometimes even in-memory storage for maximum speed.
Fine-tuning, probably similar needs.
Often, yes. Still resource-intensive, needs low latency, high throughput, high-performance file, or in-memory.
What about when the model is live doing inferencing?
Speed is king there. You want predictions as fast as possible. So often in-memory storage or storage directly attached to the CPUs or GPUs doing the work to minimize any delay.
And archiving, back to...
Back to object storage, usually. It's perfect for storing huge amounts of data long-term, cost-effectively, and reliably.
So cloud object storage really pops up a lot. Ingest, archive, maybe even feeding the training process.
It's incredibly useful for AI, yeah. The scalability and economics are hard to beat for those large volume stages. It's often cheaper than keeping everything on expensive, fast storage.
But you mentioned cost. Potential hidden costs.
Right, egress fees or frequent access charges. Some cloud object storage can get expensive if you're constantly reading data out of it, which happens a lot in AI training sometimes. So you need to look for cost-effective options that don't penalize you heavily for access.
Okay. Now, for those really high-end AI jobs, the huge models, the stuff that needs maximum performance, you mentioned specialized storage, scale-out architectures.
Yeah, for the really demanding workloads, you need more than just standard storage. You need massive bandwidth and super low latency to keep those expensive GPUs fed with data constantly. Wasting GPU cycles waiting for data is just throwing money away.
So how do these architectures work? You mentioned tiers.
A common pattern is a three-tiered approach. Tier 1. An all-flash high-performance tier. This holds the hot data, the stuff being actively used right now. Think of it as a massive fast cache. Performance is everything here.
Tier 2.
That's typically your capacity tier, often an object store acting as a data lake. Holds the bulk of the historical data, optimized for cost and scale, not necessarily instant access.
And Tier 3.
That's the application tier. The server is actually running the AL jobs, usually packed with GPUs.
And the key is connecting these intelligently.
Exactly. Matching the right storage tier and server type to the specific job's needs. You don't want to run a simple task on your most expensive GPU cluster, right? Optimize resources, maximize ROI.
How do they connect the fast tiers?
Very high-speed networking. Things like 400 gobs InfiniBand are common between the application servers and the all-flash storage tier to handle those massive data flows without bottlenecks.
And software manages moving data between tiers.
Yes. Sophisticated software handles data tiering, automatically moving data up to the flash tier when needed, down to the object tier when it cools off. It also manages data protection, replication, snapshots, all that.
Can you give a concrete example? You mentioned super microservers.
Sure. You might build the application tier with GPU-dense supermicroservers. For the all-flash tier, you can use something like the Weka data platform. It's known for extreme performance and features like GPU direct storage, which lets GPUs pull data straight from storage, bypassing the CPU, which is a huge speed up.
And the object tier.
Maybe something like quantum ActiveScale for scalable, durable object storage. The application servers would connect via high-speed interconnects to that Weka layer.
What are the big advantages of building something like this, maybe on-prem?
Well, control's a big one. You keep your sensitive data in-house. Performance, obviously, you can tailor it for extreme speed. Business continuity, setting up robust replication. And flexibility, you can adapt and scale the different tiers as your AI needs change over time.
TechDaily.AI, your source for technical information. This deep dive is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.
So, yeah, as we've definitely seen, AI and its data needs, it's a pretty complex world.
It really is. We've covered a ton today. All those unique AI security risks, the frameworks trying to help manage them, the best practices to put in place.
And then the whole data side versioning, why it's so critical and how these data pipelines work, matching storage to the different stages.
But hopefully understanding these key pieces, the risks, the protections, the data strategies, makes navigating this landscape feel a bit more manageable for you.
Yeah, it's becoming essential knowledge, really, for anyone touching this stuff.
So maybe a final thought to leave you with. As AI keeps weaving itself deeper into, well, everything, how do you think these challenges, the security hurdles, managing these immense data sets, how will that shape where AI goes next, how it gets adopted?
That's the big question, isn't it? It's this constant tension, this balancing act between driving innovation forward and making sure we implement AI responsibly, securely.
A balance we'll need to keep navigating. Something to chew on.
Definitely. It's an ongoing conversation.
TechDaily.AI, your source for technical information. This deep dive is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged and VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.